5.3 part 1 goes over solving systems with multivariables with back substitution. So when we look at these equations, you're going to have at least one of them that has the variable solved for, and then you're going to have one equation that has two variables, and then one that has three variables. Take the one that has the one variable that's equal to a number, plug that number into that variable in the middle equation that has the two variables, find for the second variable, then take the two variables that you already found, plug that into the very top, or the equation that has the three variables, and solve for the third. These ordered pairs will be in the form of x, comma, y, comma, z. Okay, so if we look at the first set of examples, we're just checking the solutions. We're going to check every single equation with all three of these variables. Our first will be x, our middle will be y, and our number to the far right will be our z. So in example A, we have 3x minus y plus z is equal to 1, 2x minus 3z is equal to negative 14, and 5y plus 2z is equal to 8, with the ordered triple of 3, 5, negative 3. So we're going to plug in the 3 for our x, the 5 for our y, and the negative 3 in for z. If we work with the top equation, we're going to have 3 times 3 minus 5 plus negative 3 is equal to 1. The 3 times 3 is 9, minus 5 minus 3 should give us 1. 9 minus 5 is 4, minus 3 is 1. 1 is equal to 1, so we'll check our second equation. On the second equation, we have 2 times x, which we said is 3, minus 3 times z, which is negative 3, is equal to negative 14. The 2 times 3 is 6. The negative 3 times negative 3 is positive 9. This would give us 15 is equal to negative 14. This one is not a true statement, so this is a no on this ordered triple. For example B, we have 3x plus 4y minus z is equal to 17. 5x minus y plus 2z is equal to negative 2, and 2x minus 3y plus 7z is equal to negative 21, with the order triple of 1, 3, negative 2. So that 1's going to be our x, the 3 is going to be our y, the negative 2 is our z. So with our top equation, we have 3 times 1 plus 4 times 3 minus negative 2 is equal to 17. 3 times 1 is 3, 4 times 3 is 12. The double negatives turn into positives. So this is going to give us 3 plus 2, which is 5, plus 12 is 17. The 17 is equal to 17, so we're going to check our middle equation. We have 5 times x, which is 1, minus y, which is 3, plus 2 times z, which is negative 2, is equal to negative 2. 5 times 1 is 5, minus 3 times, plus 2 times negative 2 is negative 4, should equal negative 2. The 5 minus 3 is 2, minus 4 is negative 2. So negative 2 is equal to negative 2. This one gives us a true statement too, so we'll check our bottom equation. So we have 2 times x, which is 1, minus 3 times y, which is 3, plus 7 times z, which is negative 2, is equal to negative 21. This is going to give us 2 minus 9 minus 14. Oops, 21. The 2 minus 9 is negative 7. Minus 14 gives us negative 21 is equal to negative 21. So this one is a true statement, which means yes, this order triple is a solution to the system. For our next examples, we're actually going to be solving these systems. So these are the ones that we're going to take the bottom equation, plug it into the top or the middle equation, then take both of those, plug it into the top equation. So this is going to give us, or this equation that we have is x minus 2y plus 3z is equal to 9. Y plus 4z is equal to 7, and z is equal to 2. We're going to take that z is equal to 2, and we're going to plug it into the middle equation to solve for y. So this is going to give us y plus 4 times 2 is equal to 7. The 4 times 2 is 8, so y plus 8 is equal to 7. Subtract your 8 over. This gives us y is equal to negative 1. So now we have a y and a z. We're going to plug those in for y and z in the top equation and solve for that. So that's going to give us x minus 2 times y, which is negative 1, plus 3 times z, which is 2, is equal to 9. Your negative 2 times negative 1 is positive 2. Your 3 times 2 is 6. The 2 plus 6 is 8. Oops. X plus 8 is equal to 9. We move our 8 over by subtracting it from both sides. We get that x is 1. So we have a 1 for x, a negative 1 for y, and a 2 for z. We're going to write our answer as an ordered triple in the form of 1, comma, negative 1, comma, 2. For our next example, we have x plus, or 2x minus y plus 5z is equal to 16, y plus 2z is equal to 2, and z is equal to 2. So we're going to take that z, plug it into the middle equation to get find for y. So that's y plus 2 times 2 is equal to 2. That simplifies to y plus 4 is equal to 2. Subtract your 4 over, you get that y is equal to negative 2. So I'm going to take these two, plug them into the top equation, solve for x. We're going to have 2 times x minus y, which is negative 2, plus 5 times z, which is 2, is equal to 16. Your double negatives turn into positives, so that's 2x plus 2 plus 10 is equal to 16. Combine your like terms, that's 2x plus 12 is equal to 16. Subtract your 12 over, you get 2x is equal to 4, and then divide each side by 2 to get that x is equal to 2. So you had x of 2, y of negative 2, z of 2. That's the order triple of 2, comma, negative 2, comma, 2. For b, we have 2x plus y minus 3z is equal to 10, y plus z is equal to 12, and z is equal to 2. Take that 2, plug it in for z in the middle equation, solve for y. That's y plus 2 is equal to 12. Subtract your 2 over. That gives you y is equal to 10. Take both your your z and your y, plug them into the top equation, solve for x. That's going to give you 2 times x plus y, which is 10, minus 3 times z, which is 2, is equal to 10. The negative 3 times 2 gives us negative 6, so that's 2x plus 10 minus 6 is equal to 10. That simplifies to be 2x plus 4 is equal to 10. Subtract your 4 over. That gives you 2x is equal to 6. Then divide each side by the 2, and you get that x is 3. So you have 3, comma, 10, comma, 2 as your ordered triple. For example C, you have 4x minus 2y plus z is equal to 8, negative y plus z is equal to 4, and z is equal to 11. Take that 11, plug it in for z in the middle equation, solve for y. That's going to give you negative y plus 11 is equal to 4. Move your 11 over by subtracting it from both sides. That gives you negative y is equal to negative 7. Then divide each side by negative 1. That gives you y is 7. From here, we're going to plug in that 11 for z, the 7 for y in the top equation, and solve for x. So it's going to give us 4x minus 2 times 7 plus 11 is equal to 8. Your negative 2 times 7 is negative 14, plus 11 is equal to 8. This simplifies to 4x minus 3 is equal to 8. We add our 3 over. That gives us 4x is equal to 11. Then we divide each side by the 4 to get that x is equal to 11 over 4. So we have the order triple of 11 over 4, comma 7, comma 11. For our last example, we have 4x minus 3y minus 2z is equal to 21, and 6y minus 5z is equal to negative 8, and z is equal to negative 2. From here, we're going to take that negative 2, plug it in for z in the middle equation, solve for y. That gives us 6y minus 5 times negative 2 is equal to negative 8. This then simplifies to be 6y plus 12 is equal to negative 8. Move your 12 over by subtracting it from both sides. That gives you 6y is equal to negative 20. Divide each side by the 6, and you have that y is equal to negative 10 over 3. Take that negative 10 over 3 and that negative 2, plug it in for y and z in the top equation, solve for x. You have 4 times x minus 3 times y, which is negative 10 over 3, minus 2 times z, which is negative 2, is equal to 21. Your negative 3 times 3 just becomes negative 1 times negative 10, so that gives you a positive 10, so 4x plus 10. The negative 2 times negative 2 is positive 4, and that's equal to 21. From here, you have 4x plus 14 is equal to 21. Subtract your 14 over. That leaves you with 4x is equal to 7. Divide each side by the 4, and you have that x is equal to 7/4. So your ordered triple, that is your solution here, is positive 7 over 4, comma negative 10 over 3, comma negative 2.